Okay, I have just a few fairly quick things I'd like to go over before we jump into the summary. So I will do my usual sharing. Week 5 is focused on input-output statements, but before getting there, there were quite a lot of emails this week, and thank you to the people that emailed me. And I realized that there are some problems with the quizzes, and which I'm still working on, and honestly considering changing. So some of those errors that are coming up are to do with spaces. Most of them are to do with spaces. I think that most of you are checking your answers in MATLAB, which is great. And then when you're entering them in, you've got to remember that to take out any extra spaces, because even though MATLAB accepts them, they won't be accepted by Blackboard. I'm going to try a couple of different things going forward, but at the moment it's still creating a problem. I have left notes, but it's still, I understand it's still difficult to remember to take out all of the spaces because you have to purposely put in spaces sometimes. There was also some other problems, but this one here is from this semester. So you see, this is perfectly valid what the person put in, but there's a space before and after the semicolon, which is why it was marked incorrect, even though it is correct. So what I did is I went through everybody's quiz and I regraded them if there were these types of problems. There were a couple of other issues too, when I kind of felt that they cropped up often enough for me to comment on them. For this, you have to read the question very carefully. So for here, you're supposed to look at the first and last, or start and end points. So actually, most people did something like what this person entered. So I gave half a point for this. And then the question at the bottom of the slide, the person forgot to name it X. So again, I see this quite a lot, so it's a row vector named X, which means that you should write an X equals. So if you don't do that, see if you put in linspace and this expression, it works, but it's not creating a row vector that is this X variable. So that's why it's not accepted in Blackboard. Okay, so last week I had a problem with this small short script, and I didn't want to troubleshoot in class because sometimes it can take 5 minutes or so, which is kind of awkward. So I went back to it after class, and I had left out this 0.37 value in the D row vector, and that's why it didn't run. It got to row 10 and it didn't work. It didn't like it. So once I corrected that, it worked okay. But I wanted to mention it for a couple of reasons. First of all, they all kind of make mistakes, and we should dig into them and solve them, which is kind of hard to do in real time in a class, but that's what we should do. But the second thing is, this is kind of a really common error when you have two vectors and later on matrices and the sizes don't match. So if you're plotting this or you're doing something with this that depends on placing in a vector, and the vectors have to be the same length. If they're not the same length, then it's not going to work. Usually the error is different though to the error that was shown in class. Usually it says that there's an unequal length of vectors, something like that. But yeah, I felt that it was worth talking about or mentioning because it's a very common error that I've seen. Okay. I did also want to circle back to interpolation versus curve fitting. I'm not sure that I stressed it enough. The interpolation was the focus for last week. And interpolation is putting points, or as it's written here, stuffing new data points between existing points. And you can use, we looked at 4 different ways of doing that last week. Curve fitting is different, and I don't think I stressed this enough last week, because actually curve fitting sometimes means that you don't go through the data points. You try to fit to the data points, but you don't necessarily go through them. And a picture's worth 1,000 words, as they say. So here, so this has an example of both interpolation, which is on the top, and curve fitting, which is on the bottom. And you'll see, hopefully you'll see, you have to have fairly good eyesight, but the curve does not actually go through some of those points on the bottom graph. So I think that's quite a good example. I mean, to me, it looks like quite good curve fitting, but it's not going through some of those points. It just goes as close as it can with an expression that it's found that fits well. Okay. Okay. Those were the kind of points I wanted to mention very quickly. And I know that there should be 2 people that are going to talk about, Stephen and David, you're going to talk about chapter 3. So I'm going to mute myself and let you take the floor.
Okay, so I'm going to start first, and then my teammate's going to pick up on the second half. So, Google, through designing a multi-layer neural network to scan through YouTube videos, unintentionally making a cat recognition machine, was one of many events in AI that caught the attention of the wider public in the new AI spring. AI is now seen commonly in many aspects of our lives, but we rarely see it as AI. The list of AI accomplishments kept going, from Deep Blue, a chess AI that could beat the best players in the world, to virtual assistants such as Alexa that could hear us and act accordingly. An AI made by IBM named Watson was even able to beat the best Jeopardy players in the world. I found that particularly interesting, so I found a YouTube video that pretty well describes it. That's a few minutes long. And I put it in chat if you want to watch it afterwards. In this new, bountiful AI spring, big tech companies such as Google and many others are putting billions of dollars into AI and scooping up all the AI experts they can. With all this funding and progress in AI, many believe that human-level AI will be here within a decade. Others believe that this period of progress will not last long, and that human-level AI is in the far future, if at all. Current progress in AI is with weak or narrow AI. This kind of AI can only do a certain task or small set of tasks. For instance, the best chess AI in the world couldn't hope to play other board games, such as checkers or Candyland, much less general games. The human-level AI that we are after is called strong or general AI, sometimes AGI, which stands for Artificial General Intelligence. This kind of AI can do everything people can do and more. It could not only beat people at chess, but translate languages and hold a conversation all at the same time. This kind of AI is likely still far from being a reality. To do what strong AI can do would likely require thought, but is it even possible for machines to think? Alan Turing, most famous for the Turing test, pondered extensively on whether or not machines could think, listing 9 arguments against machine thought and his best rebuttals for those arguments. Possibly the strongest argument is the argument from consciousness, which is that a machine can only be considered thinking when it is aware of itself, its actions, and its feelings, which the argument poses as impossible. This is a very complicated subject, and one that I believe would turn a summary into an essay if I covered it in any meaningful capacity. To greatly simplify the argument supporting machine thinking, What is the difference between simulated thinking and actual thinking if we are already biological programs programmed to feel self-awareness? The most famous barometer for an AI possessing thought is a Turing test. This test involves a judge trying to figure out through only typed messages who the robot is between a robot and a human. The Turing test is passed if the robot can fool the judge or judges at least 30% of the time. The Turing test could, in principle, determine if an AI possesses human-level thought. A demonstration of the Turing test happened in 2014, where one AI, named Eugene Gutzman, won by fooling the judges 33% of the time. Many people proclaimed that the Turing test had finally been passed, but AI experts scoffed at this notion due to AI clearly being a narrow AI that could only deliver pre-written responses and nothing else. This event shows why many AI experts believe that the Turing test is ill-fit to determine human-level intelligence. Okay, do you want to pick up, Stephen?
Yeah. So then, can y'all hear me okay? Cool.
Yeah.
There, the author talks about Ray Kurzweil, one of the engineers at Google, who's a prominent inventor and futurist who studied under Marvin Minsky, who founded the AI program at MIT. The author describes him as AI's leading optimist, best known for his idea of the singularity. He believes that there will come a point in time when the rate of change of technology will be so fast that, quote, human life will be irreversibly transformed. Namely, when artificial intelligence surpasses human intelligence. If humans could create a machine that's smarter than humans, then those machines could, in turn, create even smarter machines and so forth. Kurzweil believes the singularity is around the corner, predicting it will come in 2045. The author lists a whole bunch of his other outlandish predictions dealing with brain implants and uploading content from brains and artificial consciousness. All of this is based on the idea of exponential progress, which the author illustrates with the idea of grains of rice on a chessboard, starting with 2 on one square and doubling the value. So by the end of one row, you have 2 to the 8 or 256 grains of rice, or 2 to the 16 after 2 rows. And then by the end, you have trillions of kilograms of rice, which is an impossible number for the king to provide for the sage in the parable. So there are some elements of exponential progress in technology. The author cites Moore's law, a trend where the number of components on computer chips doubles every year or two, which means that computers get exponentially faster. And if this trend holds, Kurzweil believes that computers will have human brain capabilities in just a couple of years. On the topic of reverse engineering the brain, the author emphasizes Kurzweil's optimism about exponential trends in technology and also in neuroscience, but makes sure to point out that, quote, few, if any, neuroscientists agree. Presuming that the conditions of the brain could be recreated in a machine, it would still have to be taught, and humans take years to develop. A brain develops through interactions with a complex external world, so an AI machine would also need an education to achieve human capability, which of course Kurzweil thinks could be a sped up process occurring much, much, much faster than it takes humans to develop. So again, many people have embraced his ideas while others remain dismissively skeptical. One famous AI researcher rolls his eyes at the mention of Kurzweil's name or the mention of the singularity. Yet his ideas have inspired the current trend in the tech industry of trying to use machine learning to solve all the world's problems. The author brings up Douglas Hofstadter, who expresses concern at the juxtaposition in Kurzweil's writing of these crazy outlandish things with things that have also eerily come true. He's been very good at predicting where technology will go, and famously in the 80s predicted that by 1998, a machine would dethrone the human chess champion, which actually happened a year before he predicted it. And at the time, it seemed like a crazy prediction. Then the author closes the chapter describing a wager between Mitch Caper, who's a software entrepreneur. Is actually the first wager, I think, made on long bets in 2002, I think. The bet being that no machine will be able to pass the Turing test by the year 2029. Of course, Kurzweil took the bet, and the two laid out a very detailed set of rules for the Turing test. It's much more in-depth than the one that David described, where Gutzman was able to fool the judges. Kapor maintains that a machine stands no chance of fooling a human in this longer, more open-ended test. He makes his argument on the grounds of the complexity of the human experience, perception, cognition, emotions, and how we're shaped by our experience of being in a body and in an environment. Kurzweil, on the other hand, maintains that skeptics simply don't understand exponential growth.
And apparently politicians also don't understand. Sorry, I can't resist. So there's so much there. Yeah, well done. Very good. Oh, there's so much there. I wouldn't know where to start. Does anyone want to mention anything about Turing tests? Does anyone want to, now they've had some time to think about it, have any comments or thoughts about the singularity? Yeah, Dennis?
Yeah. So it's funny, like this chapter really, you guys can hear me?
Yeah.
Okay. Yeah, it just made me think very differently about my thoughts on AI. And what I'm thinking is Elon Musk's Neuralink. Uh, for some reason, it started making me think about like how long would it take for us to get to human level AI. And I was thinking, I wonder like if it would take about a lifetime or two using that information. Like if they were to take a Neuralink in an adult, but then I think they'd also need to put it into like maybe a child or something that's growing so they can collect more data and do deep learning in that way. It made me think about that. I know I'm just kind of just saying random stuff, but this is what I was thinking about listening to this chapter. Um, but also, this idea of could machines think, it made me believe that they probably can, rather than it just being called simulated thinking, because there's been a lot of things that we've already created, like cloning and just different aspects of birth that are simulated in a way, but it's still considered a birth. So I think if the thinking is simulated, then it's probably thinking if they do it the right way, and that's what I gathered from reading this chapter.
Yeah, I mean, it's a huge, I think it's a huge gray area. It's so when do you get to the point where it stops being simulation and actually starts being something that's supposedly real or supposedly human? Yeah.
Yeah, I think it would take like a lifetime or two. They would need to gather a lot of data from at least maybe two people from birth to death in this Neuralink program. I don't even know how it actually works, but if it's collecting that kind of data, then maybe that's the kind of deep learning that we would need. But I don't think just machines alone is going to do it. Like all this weak AI that we have is just collecting data, but since it's not really kind of synchronizing with the other stuff, I don't really think that can
Right.
happen properly until we get like a more organic component to it.
Okay. Anyone else have any comments or thoughts they'd like to share? Yes, Stephen?
I was curious about the Hofstadter character in the chapter, and it does turn out that the author, Melanie Mitchell, studied under him, which I only note for, potential bias.
I think she does a great job of not biased.
She doesn't like sell his idea more than anyone else's, I would say.
Yeah.
But it is interesting that she comes from his school of thought, and I looked him up and read an article in the Atlantic about him from like 2014, and he seems like a really fascinating individual. If anyone else is interested in and his whole thing is like, rather than like he writes programs not dissimilar from like the chess winning program, but he's very adamant about not calling those machines intelligent, and he's very interested in digging into like what is human cognition, and his ultimate goal is to understand cognition through programming computers to behave like people, and studying how the brain works that way, which I find just fascinating. I don't necessarily agree with his approach, but I think it's very interesting.
Yeah, thank you. Anyone else would like to say anything? It certainly was a chapter full of, yeah, Jacob?
Can you guys hear me? Yeah, I just thought the one of the things about the Turing test that I thought was kind of interesting is that, like, I think when Alan Turing created it, he didn't really establish parameters, so it wasn't like a really efficient test. And there was like the example that they gave about the testing participant was like fooled, but they think like any kind of an expert who was in the same judging position wouldn't have been fooled in the same way. So it kind of created a necessity for some more stringent testing parameters for that.
Yeah, it seemed like that Turing test was full of holes. I think that they certainly learned a lot from that. Okay, so is anyone wanting to volunteer for next week? I'm going to make this the last week there are volunteers, and I'm just going to assign after this week. So if anyone wants to volunteer, this is kind of your last chance. Or if you want to do a chapter, if you're interested in a chapter, you can always email me this week and let me know which one you'd like to do.
I'd be interested in chapter 4, if that's possible. The next chapter.
Is that Jesse?
Yes, ma'am.
Okay. Yep, that's great. Anyone else like to join Jesse? Hey, Jacob? Okay, that's great. Thank you so much. Okay, I'm going to share my screen. As I was saying, I think a couple of you missed it, that I've been having a lot of technical problems, and I lost my MATLAB license. I'm still not entirely sure what happened. I have been using the online license. So anyway, we'll see how that goes. So this week is focused on input-output statements. What the heck does that mean? For those of you who have done some programming, this should be fairly straightforward. But if you don't know programming, this is all very new. So it's worthwhile saying that you usually have a program. In this case, we have a script. And the script is going through a list of commands or instructions or number crunching, say, or decision making. We're going to be getting there. Probably next week we'll get there. But generally, it has some data to work with. So that could be input from an Excel file, or a person could input the data, or maybe it's being input from a sensor, but it's being fed some data usually.
Professor?
Yes? Yeah, sorry.
This is about the chapter 3 summary. It says that it's due today at 2 p.m. Is that correct?
No, I will change it. I'll change it afterwards. Okay. Sorry.
Do you know when it's actually due?
The chapter's due. Well, this is chapter 3, and it's supposed to be due at 7. I opened it and I made it open between 5 and 7 today.
Okay. All right.
And give you time at the end of class to do it. But thank you for the question. I'm not sure why it says 2 o'clock. It should say 7. If there's a problem, I will change it.
Thank you for answering it.
Okay, and after we've gone through this number crunching, it's gone through the program, then there's generally an output. The output could be a value, or it could be a plot, or some kind of display. Now that might be stating the obvious, but we're going to take a closer look at this. Okay. I'm going to go to MATLAB, fingers crossed. Okay. So here is going to be a new, I hope you guys follow along with me. It's going to be a new variable. Oops, and I'm going to call it input. New command, and that means I would like an input. Okay, so this is going to prompt a user. So for example, please enter a number. Okay, so going to be creating a variable y1. It's looking for an input, and it's going to print, please enter a number. Okay, so it says, please enter a number. So I will enter the number 9. So you'll see in the workspace, wherever your workspace is in MATLAB, there should now be a y1 with a value 9. Okay, if I do something quite similar, but this time I'm going to ask please enter a letter. Okay, return. So I'll put in the letter T. It doesn't like that. Why doesn't it like that? I'm making an error on purpose for everybody who gets worried. Yeah.
So sorry, ma'am. Because there are no quotes around it.
Okay. Yeah. Yeah. That's close to what I'm looking for. So yeah. So it's expecting by default a number. It's expecting, some kind of integer or floating point or something like that. That's what it's expecting. So if I want to input a letter, I have to give it another command or have to give it more information. So you'll see here, as I'm writing it in, it says prompt. So this is the prompt. This is what we're writing in terms of, instructions. And then afterwards, it has this option to put a comma and in apostrophes an S. Okay, so I'm going to try that this time. Okay, please enter a letter. Try again, and it's taken it this time. And if you look over here, you can see these building up.
I'm sorry, why did you put the S?
To tell it that it's a string. To tell it that that I'm going to be entering a letter. I need to tell the software that I'm entering a letter. It's expecting by default a number. So I need to add a bit more information to tell it to accept a letter. Okay, Dennis?
No, I understand. I guess it's just, when you first put please enter a letter and then, a number, and you typed in a number, it was fine. And then I guess it's obvious now that I'm looking at it. I just didn't understand why the S was there. I get it.
No, so if I don't know how much programming you've done, Dennis, but when you've not done much programming, and I would not call myself a programmer, but actually this section in here means nothing to MATLAB. It means absolutely nothing. This is just something it's going to spew out at the user.
That's the part that confused me, but I get it now.
Yeah. So even though what you're saying in here is meaningful to you and to another user, to the computer, it means nothing. It's looking for this input. It's expecting you to input something, and by default a number. So you have to put this in this part in here. Say what you should expect is a letter. Okay. Okay, so if I put in something like name equal to put, please enter a name, right? So obviously it's looking for a letter in this case. I'm going to put in Vincent. And here you can see that it's, for some reason, it's not saving to my workspace, which is super, super worrying, but we're just going to continue hoping that it's actually saving the correct thing to the workspace. It's wonderful when technology works, and it's really annoying when it doesn't. But if I now put in, F, this is the second thing. F print F. Okay, and I write my name is. Now, if I wrote in something like "Hello World," I don't know if you guys have done this before. If you've done any programming, you've done a Hello World program at one point, and it will just like print out "Hello World." But I want it to print out my name. Okay, so I'm going to do F print F. My name is, and I have to tell it that it's a string type. And then here I go name. I'm a little worried about what it's going to show. My name is Vincent. So in other words, completely ignore the workspace. The workspace is not keeping up with me. But this is an idea. This is a way that you would display information. Okay, so this might be a little bit confusing right now, but the first command at the top would be taking information in from a user, and then potentially one way of printing information out. So say you've taken a lot of information in by using this input command, you're doing different things with the information, and then you want to display some information, then you would use F print F and then display what information you want to. Okay. I'm gonna clear that. Any questions at this point? Okay, so this is an example here of, so this is a script. So I'm putting in a couple of different input statements, very similar to what I just did. Entering in a number, entering in a name. And then I have a lot of F print F statements, and those I'm going to print out the number 4 times, but take special care to look at these at the end, okay? And you can get a better idea of what those are once I've run the script. And then at the bottom, printing out the name. Okay, so let's run it. So let's do 8. Okay, so I entered in the number 8, I entered in the name prof. And so here we have the number you entered is 8, which is what we expect. But right next to it is the number you've entered in is 8. And that's because this first command here does not have this backslash. You need the backslash to have a new line. Okay, it makes a new line. That's what that means. So here, it's been done, which is why after it's printed out, the number you entered is 8, it creates a new line. Now this one here has a lot of zeros, and that's because it's an F, which is floating number. So it prints out all of those zeros. The next line, it only has 2 zeros. And that's because this f.f you've entered is, the number you've entered is, has a point, and then 2. 2 refers to the number of places after the digital place. So it's going to, in this case, going to print out 2 zeros. So I'm going to go to the last one because that makes the most sense, which is printing the name. And it has used S, and the F, and therefore it's just your name is prof. But before that, this one, it says your name is, but the type is expecting is an integer. So it's actually printed out prof in integer form. Okay. If I wanted to save something like a number, but I wanted to save the number not in a number format, but as a character format. So for example, something like, a phone number. Phone numbers, we don't generally manipulate them. They're representation. So maybe I want to store a phone number for some reason. In that case, you might want to save the phone number as a character or a string. So in that case, you would say enter a number, please enter a number, but actually you would still add this on at the end. So that would be stored as a character. And similarly here, it's thinking that I've stored, the name has been stored as an integer, so it's trying to display it as an integer. And I get the feeling every now and again that I'm staring at my computer talking to myself. So I have to come back to some faces, because otherwise you go a bit crazy after a while. I hope that made sense. I'm going to, yeah.
Oh, I'm sorry. I was just sighing. I just don't like the fact that you use colons to do different lines you're doing the matrices, and now you have to do the slash thing to go to the next line. Like that, I know that's going to be a problem at some point.
Yeah, I feel you. I'm looking up this stuff all the time. And you have to remember it, yeah. But luckily, MATLAB has a great help section. So I would like to propose doing an exercise on this. I'll bring it up. There, see if I can actually see what it is. So I'm not sure which one you'd like to do. If you want to take like a screenshot of this, and you can decide, because I'm going to do like a breakout section. So you're going to create a script, but you can choose either one of these that you'd like to do. Just choose the one you think is going to be more fun. The first one, you're going to be entering in points and then plotting those points. Or the second one, you could take a number from each person and then find the mean and median number and plot that or display it, one or the other. You don't have to graph it. You can just plot it if you want to. Sorry, print it if you want to. Okay, so take a screenshot of that so you know what the options are. Does anyone need any help with any of the commands or anything before we get going? Or you think you're going to be okay? Hopefully, it'll be in big groups, so somebody will have remembered. Okay.
I wasn't able to take a screenshot. Can you show it again?
Sure. You got it?
Yeah, thank you.
You want to take a screenshot of that one if you want to remember what all these are. I'll let you guys take a screenshot if you want. Oh, I was an application engineer, so I'm a big believer in screenshots. Okay, let me. One moment. This takes a couple of minutes. Okay, this is going to jump you into the breakout sections. Okay, let me know if you have questions. I'll visit you just once. Okay, so it'll be about 15 to 20 minutes. Okay. Did anyone want to share anything, or
Sure,
you all got on?
I can share my screen to show where I'm at so far.
Yeah, sounds great. Go for it.
So this is what I have so far. I've got the month 1, 2, 3, and 4 based on this is based on option 2, based on entering the teammates the month that they were the month of their birthday. So that's for teammate 1, 2, 3, and 4. You'd enter the first teammate, then the second, then the third, then the fourth. Then it would add those as a vector I assigned to A, and then it would calculate the mean of that, and then it would calculate the median of that, and then put those on a graph. Put those both on a graph with a red circle, just to make it easier to see. And I got the median working, but the mean not quite. If I run it, I enter teammate's number. That would be mine, January, then February, then August or September, I don't know, just 7. And then September, the other one is July. So July and then September. Then it pulls up a graph. I don't think you can see this graph, but right now it displays a red circle at
Yeah, we can see it.
4 point. Oh, you can? Oh, that's good. At 4.7. Oh, I see. It took the X value as the median and the Y value as the mean. Or maybe it's the other way around. But that's about where I am so far, so it doesn't work the best, but it at least displays the values.
Very close. Yeah, it's good.
Thank you.
You need to put median in a bracket, in a
Yeah, a different plot.
Or use hold on and then plot it again, something like that. Yeah, it's good. Anyone else? And if you didn't get it working, you want to say where you got to?
Sure, I'll say where we got to. So I noticed that for each input, he had a line for it, like number 1, number 2, number 3, number 4. The problem I was running into is first I was trying to put all the inputs in one line. And once I was putting in the command for a name, I was stuck in this loop where I'd have to turn off MATLAB because I couldn't get out of it. Do you know what I'm talking about? Like if you put in the command for a name and you're pressing enter, you can't CLC or clear out of it. So I did that a few times, and I had to like go back to my notes to look at the commands for plots, but I didn't do well. I was confused because I'm thinking there's only an X, there's no Y. How do I plot this? So I was a little bit lost.
Okay, anyone else? Any of the other groups? Oh,
I just
I
wanted
was
to
kind of
mention.
trying to figure out the
Oh,
same thing too, about how to end it because I would do like I found a way to get out of the loop, but I don't think it was correct. I was running into the same thing though.
I just wanted to say that if you ever get stuck in an infinite loop, you can hit Control C a few times. It'll usually close it.
Yeah, I just put end at the end. I just wrote end at the end of my script, and it crashed my program, I think, which happened to make it stop at the end also, but it didn't not I didn't do it how I wanted to.
okay, well, well done, David and David's group. Even if you did get an infinite loop, you still learned something from it, right? Okay,
I've waited hold on and just putting in a second plot that worked fine. So now it's working correctly. So thank you for that.
okay, thank you.
Sorry, David, could you take your code and put it in the chat?
Sure.
Thanks.
Okay, so I hope you guys are kind of following along. I think it's really boring if you're just listening, but you're welcome to do either. So this time I'm going to actually do a different option, a different way. So what I'm going to try to do now is create a dialogue. I'm going to create a way of having a list that you can select from. Okay, so a little bit of patience while I write this in. Okay, so usually with these, we want to put in some information, some comments so that we know what it is when we open it up. It's very important because you will not remember later. Just put something at the top. You can, of course, discard this later if you want to. Now I'm going to create some row vectors. Hopefully this time I will enter them correctly with all of the values that I need to do. It should have 4 entries. Okay. For some reason, I always make a lot of typos when I'm doing 2 things at the same time. I'm not built to do 2 things at the same time. Okay, so I've built a row vector that has 4 values: 12, 5.375, 11, and 11.875. What I'm doing is that I'm building options, 4 options for a box, and the box has, for these 4 options, have different lengths, widths, and heights. This will make more sense in a moment, but we're just going to enter the data for now, and then I'll go back and go over it a little bit. Okay, those are the widths, which is 12, 8.675, 8.5, and 3.375. So now all that's left in terms of the data is the height. Okay. So to understand this, there are 4 options. The first option would be a box that had length 12, whatever the unit's going to be, width 12, and height 5.5. So option 2 would be length 5.375 with width 8.675 and height 1.675. I hope that's making sense. So here, as is keeping for today, we're going to allow a user to select a box. Okay. And I'm going to create this list. That's not actually the command. This is another way of just entering data to make it a little bit more clear, believe it or not. You might not. But let's do that. So I have these different options. So for the first option, it would be a 12 by 12 by 5.5. Okay, so I'm not going to write that in for every single one. Okay, and then this would be optional. In the interest of time, I'm not going to write every single size in. Although if I was doing this properly, I would. Would I do that every time? Okay. Okay. Excuse me while I wonder what. Why is it not liking that? Okay. See. Okay, the actual command is not liking something about it, so I'm not sure yet. Take a look at it in a minute. Would be this index TF is equal to the dialog DIG DLG.
So I had a quick question.
Yeah.
So with brackets and parentheses, as long as you're consistent, does it like not matter what you start with? Because at first I thought you had to always use parentheses, but using brackets in a lot of these operations, meaning so length equals bracket 12, 5.375, so forth. It doesn't matter whether you started with a bracket or parenthesis.
No,
As long as you close it with the same one. I just thought that it was supposed to be parentheses, but I've seen a lot of differentiation with the different commands.
I think that maybe it's my terminology. I usually use square. In America, they're all parentheses, right?
Oh, the brackets are the ones that are next to length. That's what I'm referring to. And then next to list are the parentheses. And I was just trying to figure out if it matters what you use those.
Yeah, so there's different ways of doing it. So this is just one. I'm sure there's different ways of putting in row vectors. This is one way.
Okay.
So I'm gonna. It's not liking something about this. So I'm gonna run it and see what it is. All right, yeah, that would help. I saved it as something. And for the second week in a row, don't see any difference. Ah, yes, okay. So to your point, this is a curly parenthesis. It's always parenthesis. Anyway. Okay, yeah, okay. For those that missed this, when I'm doing this list here, this here needs to be a curly, I don't know what you call this, a curly parenthesis. I don't know what you call it in America. We call them curly brackets in the UK. Okay, so that's now okay. Okay, so it's already, so here we put in these lengths, widths, and heights. We have 4 options, and it's if you've been watching, you've already seen that it creates this list from these options. This is the command to generate that list. When you select something from that list, it will store it, and you will see that, hopefully, you'll see that in the workspace. The workspace is lagging, unfortunately, online. I'm not sure why, but it will be stored. And then we use that to do our calculation of volume. So I'm just creating a variable, volume. So the volume is just, length times width times height. So I'm going to write in, we already have length, right? But we need to know which length, and we need to know which length from the selection. So that has been stored, and it's stored as index, okay? So I'm hoping you're following this. Here are the 4 different options stored in their place in these vectors. Here it creates a list that the user selects, and that position in the list is stored as this index. And then we're using that position to grab from these row vectors which length and which height and which width. Okay. Now I'm writing in length, width, okay. And I could also do it for girth as well. I might leave that for now. I feel like this is taking a while. And then what we have, that's all very good, but then it would have that information, and we're interested in seeing what the information is. So we need to display the results. So we're going to use printf. Okay. Volume is going to do. So I'm using. And go to 4 places past the decimal place. And I need to tell it that it's volume. Helps if you spell it correctly. Okay, it's not going to work yet, but we can try it out. Okay, so let's see. Run. Okay, so it has these 4 options. So I'll select the second option. So once I select that, I'll go OK. And you see how in the index over here, it puts in 2 because it selected the second from the list. And then it calculates that volume. It's really to put a semicolon in there, otherwise it will print every time. Okay, I hope that was clear, or at least somewhat it made sense, maybe not completely clear. I'm getting that feeling I'm talking to myself again. How was that? That makes sense. It will be on the slide, so you can take a look on the slide. I did want to show something, especially to the people who are more advanced at programming, because there is a very obvious error actually. So let me go back to it. So if I do run it again, it has this down here by default has a select all, which is it's not going to work. Okay, so if I go okay, it hates it, right? That makes no sense. Can't select all because based on this, it's looking for a value. So because of that, on the, I hope I'm actually sharing the screen here, not just MATLAB. Where is it? Okay, so in here, there's this web page. You guys do see this, yeah? Not the web page, the slides?
Yeah.
I'll assume so. And if I go to this, okay, so this is the help center for this command. And if you go through this, it has all of these different examples. I find the examples super useful. And if you're going through, you'll see the select all here. But for this one, it's not there because it's on the selection mode single, which is an additional command within the list dialog. This is what listdlg means. And that eliminates this box. So if I add in this list dialog, I think I have to one of these. Yeah, here we go. So if I add in this to the command, it will not print that. It will not create that button. Okay, I just wanted to circle back to the help to show you how adding in more commands can change. I know for some of you, it's like, oh my goodness, she's starting to build, Windows dialogues and next will be on to GUIs. No, not really. But yeah, this is the kind of stuff that you can do. It's really diverse and a powerful piece of software. Okay. Any questions at this point?
In that the piece of code that you just typed, that percent point 0.4f, can you explain what that was?
Yeah, so the percent point 4 f is for floating. That's the type of data I'm looking to use. So floating point, the decimal place floats. That's how I think of it. 4 means how many significant digits past that decimal place. You can leave it at default. It'd just be super long numbers. Yeah. Okay.
Thank you.
I have a quick question. When I put in the script as you had it, the fprintf, the volume is percent 0.4f, and then when I run the script, it repeats it 4 times.
Oh.
Actually, I need to look into this. I think there might be another error going on in here now, but
yeah, I'm not sure. I would have to take a look at your file. Okay. Oh yeah, and I did want to say that if you do have errors, if you do have problems, it's always good to, part of this is learning how to deal with these errors and problem solving for yourself, and that is frustrating, but the more you do it, the better you get at it. If you really are stuck and fed up, you can email me and put the M file in. It helps to have at least the M file or at very least a screenshot so that I can see what's going on and at least give you a suggestion. Okay. Okay. So I should have done that one at the beginning. What can we do? So I'd like you to try just playing around yourself. I'd like you to try to print out my name is, and the X will be your a variable that you've created that you get a user or yourself for now to enter. And I am whatever years old. You feel free to lie. It's just we're just messing around here. Okay, but if you can have a go at trying to print out your name and your age, or maybe something more interesting than that. Okay. So how is everybody getting on?
Okay, I haven't run it yet though.
Yeah, that's always the test.
Right now I'm having trouble with the print function, actually printing something out.
Well, I did something super basic. I mean, super basic, and there are different options on the slides. If you want to take a look after, you can take a look at that. So I did favorite number. Oops. And enter your name. So my favorite number is 4. Your name is 12. You know, this certainly could be made way more sophisticated. So the last thing that I wanted to go over, and it's kind of an introduction to what we're going to be doing next week, and it is a for loop. Before I do it, how many of you have done loops? How many of you have done loops in programming? Okay, quite a few of you. So for you guys, this will be relatively straightforward. And in programming, as is often the case, or scripting, whatever you want to call it, you tend to come across sections where there's a lot of repetition, for example. And because of that, we use loops. There are more reasons than that, but that's one of the reasons. So one of those types of loops, one of the simplest types of loops, is a for loop. And if I go to read the script, yeah. And I write in, so the for loop starts for, unsurprisingly. And then here you have to say, and not so much how many times it's going to do something. I mean, you could explicitly tell it you're going to do this certain thing X amount of times. Or you could do something a little bit more sophisticated. I'll start with something very unsophisticated. So now we're used to this type of thing, you know, because this is essentially going 1 to 10. Hope you recognize that this is going from 1 to 10. And I'm going to use the trusty fprintf that I hope we're all getting used to now. Value of A is Oops. And then I have to actually tell it. Remember, what's in here is meaningless to the computer, right? So we have to actually tell it what that is, and that is A. And then, very important, you have to end. Right? For loops, you have the beginning, and you have to close it out. Okay, fingers crossed. Don't recognize. Okay. Doing. Why is it? Okay. Okay. And why do I always do it with quotations? It's like it's a pathological thing that I do.
It's the first
like-
line.
Yeah.
It has to be a comment also. The parenthesis. I mean the
Thank you.
percentage.
And it's still not working.
Oh, won't it have to be %I before the new line character?
Yes. How many mistakes that you can do, and like what 20 characters? Yeah. So you can make this a bit more interesting. You go from 10 up in 5, 50. Run this. Now it's going up in 5 to 50. Yes, we've got kind of get used to this kind of format. Another and different way and more efficient way of doing the fprintf here, since we don't always need to write value of whatever. Something else you could do is use a different command called display or dis. So here it would display the numbers, yeah, instead of the fprintf. Fprintf is useful when you have, you want to describe what it is. Yeah, you want to put in some writing. Okay. So if you wanted to do, let's see, better tell it to write and put in an integer. Okay. Okay, so I'm going to ask to put in a number greater than 0, less than 10. And I'm going to go from 0 to 6. Wish me luck. If you see any mistakes, let me know. Okay. Okay, I'll enter 8. And then I'm in the wrong window again. Okay, and it goes from 0 all the way to 8. And I should really do display. Yeah, well, that's right. Okay. The whistle stop through for loops. I hope that made sense. Any questions on that? Everybody looks so serious. We're just messing around with for loops. There'll be more loops, more different types of loops next week. Okay, it's 6:40, and this is really just an input-output statement. Also, we have to do the summaries. I still haven't let you have time to do the summaries. So we will finish now, and you guys can go and do your summaries if you haven't already. Maybe you already wrote them. And I will see you next week. Hopefully my regular version of MATLAB will be back and I don't have to use the online version. Okay, that's it.
Thank you, Professor.
Thank you. Take care.